Hello, everyone. Thank you very much for coming. My name is Luis Pavon, and I work at Portworx. Today, we'll be talking about securing your gRPC applications. Okay? A little bit about me first. Again, I said my name is Luis already. I'm a CNCF technical lead. I'm also been participating in Kubernetes since I think 1.4. I remember going to KubeCon in London, and it was much, much smaller. It's probably the size of just this side, right? I'm also been participating in CSI since its inception. And before working at Portworx, I worked at CoreOS and I had storage. And actually, that picture you see right there, that's from Big Hero 6. My sister sent me that picture, and she said, I think you're in the movie. And so that guy kind of looks like me a little bit. Probably a few years ago when I had more hair, though. So anyways. All right, so a little bit of history before we go ahead and we talk about authentication and authorization. Why is it that we started this project at Portworx? One of the things that we had to do was first, our customers were asking for a method to integrate the libraries of Portworx and control system into their applications and how they manage users. So what we did first is we created a gRPC SDK. And that worked well, and then after that, they said, well, we want to also have certain applications have certain rights, and we also want certain users to be able to access certain volumes and not others. And so that started creating what we're going to talk about here. So this talk is specifically on our experience on how we were able to achieve this through authentication authorization in gRPC. Okay, so what is authentication? Authentication is when a system is trying to find out who you are or who the caller is, determining that person who they say they are is true, and then they authorize that person or that caller to determine if they are requesting, they can go ahead and actually do. Okay? So let's first talk about authentication. Anybody know what this is? Sneakers, that's right, yes. That movie came out about 92, I think. And you can see how important security was even then. They made a movie about it. It's actually a pretty fun movie. You should go watch it. But in this movie, the way that authentication was done was by the voice of the person. They had to say these words, and then they would have a voice recognition system, and they will allow them to go in. The point of the movie is that they record the person with an audio tape, a very analog audio tape. They record every single word that the person said, they put them all together, and then play back, and then can get in. So they were able to achieve that. So security is very important, even for a long time now. So when we started this project, we said, okay, we understand that we need password management. We understand that we need a method for us to determine who the user is. Okay, so what we started going into the libraries in Go. Started checking out other projects that had security models. So I looked at bcrypt, and I looked how bcrypt is able to store passwords and able to manage passwords and so on. So I called a friend of mine. His name is Eric Chang. He is a friend of mine from CoreOS. He now works at Google. He used to be a SIG-Auth lead. So I said, I have this idea for authentication and authorization. What do you think? It uses bcrypt, it uses passwords and all this. It's pretty nice. You log in, saves your password and stuff like that. You know what he said? No. 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 Don't do that. You do not want to do password management. You don't ever want to think about doing password management. Strike that from your mind, okay? The only thing you should be doing is verifying a token. That's the only thing. And this is the way he said you should do it like Kubernetes. That's what they do, right? Something else creates tokens. You get your token to Kubernetes for an API call, and Kubernetes can then verify. You should do exactly the same thing, okay? And actually, I want to thank Eric because we have brought this model over to some of our customers. And they have a huge audit sheet of things, to how you do password management, things like that. And the really nice thing about it is that most of them, we say, does not apply. Does not apply. Does not apply. Why? Because we don't do password management. All we do is verification of tokens. How long do you hold the password? Does not apply. Where do you store a password? Does not apply, right? As long as you get a token, we verify it, then we throw it away, right? Okay. So how do we actually get to do this verification of tokens in gRPC? We chose two models. I mean, that's really one model using the ubiquitous JSON Web Token. I hope most everybody knows what JSON Web Token is. Everybody good? Okay. So then what we need to do is also make sure that applications can generate tokens for gRPC. We call that a trusted issuer. So let's talk about JWTs first for those who are new to this. It's just a bunch, it's a large string. Okay? A token is just a large string divided into 3 parts. And that's what a JSON Web Token is. The 3 parts are the header, describes the token itself. The claims, the most important part, describes the user, groups, roles, whatever you want. It's just a whole bunch of JSON blob. You can put whatever you want in there. And then there's a signature. The signature is the contract between the token issuer and the verifier. The contract where you need a certain method to go ahead and verify that the token is correct and it hasn't been tampered with. So once the token gets output into some large blob of text, it is immutable, okay? All right, so we understand now what a token is. It's just 3 parts of string. It has the claims, it has the signature. But how do you generate the token? There's actually a couple of models that we actually use for our implementation. One is that you can use the normal JWT libraries for many languages to go ahead and generate a token, as long as you share both the verifier and the generator of tokens have to have a method to determine that. One is to do a shared secret, right? We have one secret to generate the signature, and then you have a secret in the verifier that makes sure that that signature is correct. You can also do a public key, private key model, where you have the private key being able to generate tokens, and you have the public key to be able to verify. And then there's another, that's up to you. In our model, it was up to our customers. We let them have the freedom to be able to generate all these tokens in any way they want, Python script or whatever. But then there's another model called the OpenID Connect, OIDC. OIDC is a standard that allows your system to connect to which can manage thousands of users. Right? So I'll go into OIDC in a second, but let's talk about how generating a token works. So here's just a little bit of pseudocode. And you can see from here that in the claims, again, the JSON map, you can store things like the sub. The sub, according to the standard, is a unique identifier for your user. We got the ISS, which means the issuer. So when the token gets to the verifier, the other side, the verifier checks the issuer and says, do I trust this issuer or not? So you can't just have anyone generate a token. You can only have the token come from those who you trust. Okay? Then there's more information about the caller, like the email name and things like that. And then there's expiration date and the issued at time. This is just a little pseudocode. And now I'm going to start showing a lot of Golang code. Just get ready. And I don't want you to start reading through it right now. Every one of these has a link at the bottom. And you can click on that link and actually shows you our open source code that we actually use in Portworx to do this. So you can see real examples. So OpenID Connect, again, is a service. You can use this service to be able to connect between your gRPC service and something like Active Directory or LDAP. For example, one of the ones that we've tried and works really well is Keycloak by Red Hat and Dex by CoreOS. For example, in Keycloak, you can map different sections of an LDAP, like roles and groups, to what Portworx is looking for. Okay? You can also have users. Keycloak can have its own database for users if you have just maybe a few hundred. But if you have thousands of users and you want to track them, you can connect it to an LDAP system. Then there's also service on the cloud, like Okta and Auth0, and then other OIDC compliance systems in Google and AWS and Azure and others like that. So, all right. So we understand kind of the big picture of authentication. How does it actually work implemented in Golang? So if you've done JWT tokens in REST, it's a lot like that for the client, where the token goes into the metadata of the call. In a REST call, it goes into the headers, which again is the metadata of the call. And in Golang, in GRPC, it goes into the section called metadata that you can access through Golang APIs, or here's an example of how to do it in Python. And in there, you store the authorization bearer token. Okay? So it's pretty simple. There's not much to do in the client. If you don't want to do this, for example, for each one of your calls, you insert the token in the context every single time in Golang, you can also do something that's called interceptors. And interceptors allow you to catch your calls going out and then insert the context every time. Now, let's talk about the server side. That was a client. It's pretty simple. It's done. The server side is a little more complicated. And this is really one of the reasons why I wanted to do this talk. There's very little information about this out on the internet, and I wanted to kind of just put it all together, like a little compile program, and then send it out to you. So the way it works is that we're going to use the technology called interceptors, which if you've used OpenStack Swift or Python Whiskey server, you have these filters that do in the pipeline, and they pass environment to each other. If you've written Windows device drivers, they have the stack you can send from one to the next and the next and so on in the stack. So in the same way is how interceptor works. So here's a very simple interceptor for the server side. Every interceptor has that same function, a set of arguments. In this example, we take the context and we insert into it some value, some key value. And then what we do here also is, in this example, this is specifically for Golang, we are also passed the actual GRPC function that's being accessed in the function info.full method. And in this value here, we get to print it out. And then we go ahead and call the next handler with the new context that we have adjusted. So the next handler now has that some key, some data information in the context. So that's just a generic interceptor. Now let's start focusing on an authentication interceptor. So gRPC has these Golang libraries, or helper libraries, to be able for you to do authentication of JWT tokens. The way you set it up is that when you set up a gRPC server, you have to do the following to be able to stack all your interceptors in order. So in that order is how the server is going to call your interceptors. So you want your authentication most likely to be first, so that way you can authenticate the call and then set up the context for the next calls. In this example here, we just have the simple interceptor just as like a logger, and then we have this wrapper around our auth call, which is here. This is a helper function that comes with Golang and the gRPC library. And this helper function gets automatically just the context, and from it, we call another helper function to extract out the token out of the call, out of the metadata. Once we extract the token out of the metadata, we just call some verified token function, whatever you have for your system. There's a lot of Golang libraries to be able to do this. We use the JWT Golang libraries to do this, so this is how you implement it in your way. All right, so here's the library that we use, is JWT-Go. And again, I have lots of examples once you see these slides. These slides are on my Golang, on my GitHub repo, actually. And then we also have a way of verification with OIDC. How is it that we set it up? You have to have OIDC client to be able to know where to connect to and things like that. The OIDC model sometimes is a little bit simpler. It depends on the deployment. All right, so we talked about authentication. Now let's talk about authorization. This part was a little bit more complicated because in authentication, we had a lot of helper functions being able to, from the Golang library functions for GRPC to help us with this. But for our RBAC, we had to kind of come up with something. And again, this is how we implemented the method. It's an example. You may look at this and adjust it to your models. But I just wanted to give you a start on the way we did it. So we have an RBAC model for our open storage SDK, which is a GRPC SDK. And everybody here, hopefully, understands the Kubernetes model, right? The Kubernetes RBAC model is based on verbs like get, list, patch, right? And so on. But we needed to do something like this for gRPC. But gRPC doesn't have the same verbs, right? Those are HTTP verbs. So here's an example. We have a gRPC service called route guide. And in it has two RPC functions, get feature and list features. Okay. So what we did was we wanted to look kind of like our Kubernetes, and we wanted to make it simple for our users to be able to do this. So what we did was we looked at the strings that the functions are called, and we say, OK, this is what I would like it to be like, right? I want a role, a key, the name of the role that has these rules. And then inside it has two sections, or an array of these two sections. And they are services and APIs. All right. So in this example, in this one role that I have here, there's a service that is allowed for this one color called route guide. And in route guide, the only API that is allowed is get feature. So according to this rule, list features is not allowed. So if somebody was in this role and tried to call list features, it will be denied. So let's figure out how we actually do that in Golang. So the way it works, it's all based on the interceptor passing in the info.full method. That has the entire path for your gRPC call. All you have to do is kind of clean off all the slashes and the things inside, like open source API. That comes from the generation of the Golang files from the protocol buffers. Just remove that, and you're left with the service and the API. And now with that information, you can go ahead and verify that the caller is allowed to make that call or not. Right? Here's, for example, a more specific example of how to do this in Golang and make a role. But again, it's the same style. As you can see here, we have a different set of functions. We have a role, and we have two API calls. This one's specific for the storage SDK. But we have two services. So we're saying you can call the volume service and the cluster service, and the APIs star, meaning all the functions in those two services. Okay? So when somebody uses this role, they're only allowed to make those calls. If they try to make another call like node or something like that, they will not be allowed to. All right. So how do we do this in Golang again? How do we actually implement it? The very first thing is that we need to find out information about the caller. And we do that by going to the context and extracting out the information that was placed there by the authenticator interceptor. Okay? So the authenticator interceptor was called first. It made sure that the token was OK. It extracted information of the token, saved it all in the context. Now the next call comes in, extracts information out of the context again. It sees, oh, this is Luis, right? He's trying to make this call. And then it goes ahead and calls the verify for Luis. And it says to make sure that this call is allowed or not. Okay? And that's how we do RBAC support in gRPC. Now, here's another really cool thing. So I was doing debugging for this call, this interceptor specifically, and I created something I didn't even mean to create, right? I wasn't even planning on doing this. I created an auto log. I didn't even plan on doing that. It just happened, right? I was tracking every single call that came through every user, and I was logging it, right? I was logging if it was successful. I was logging if it was not successful. Now we have methods to track each one of these, right? We can actually take all these logs everywhere and put them in a panel. We can actually do the auto log to determine if we have somebody maliciously coming in, attacking, right? Okay. So that's authentication, that's authorization. But some of our customers also said, "Will, we like GRPC, that's great, but we still want to use REST." I said, "Okay." So what do? There's a service out there that is called the GRPC Gateway. And this is really nice because, and I highly encourage you to stop writing REST services and start writing GRPC REST services with the GRPC Gateway also. The way it works is that on your GRPC service, you define the path, okay? And then what happens is that when you deploy your application, your service, you start up a REST service that's generated for you by the GRPC Gateway. You start this gateway, it takes in the REST call, automatically changes it to a GRPC call, and it calls your function. You have to write a single line of code to be able to support REST, okay? The really nice thing about it, too, is that it supports authentication. It takes the authentication headers from REST, where they're supposed to be, and then grabs them and puts them into the metadata for GRPC, and then makes the call ahead. So now you have support for authentication, authorization in REST and GRPC, and whatever model your customer wants to use. All right. So I have 15 minutes. That's pretty good. I have a live demo. Good? So, you hear me okay? There we go. All right. So on this system, I have, let's make sure I have the internet. Everybody can see that okay? I can make it bigger. So I have 4 nodes and running 1.15.5, okay? Actually, I didn't show you this slide here. Let me talk about this slide first, and then I'll show you the demo. So what we wanted to do in this demo is some of our customers, too, they wanted a simple way. They don't want to use ORDC. They just wanted to secure the communication between Kubernetes and our storage system. They wanted to make sure that Kubernetes doesn't have the entire RBAC. They want a specific RBAC for Kubernetes. And they wanted administration tokens to be run only on the command line. So what that means is that the customer is leveraging the Kubernetes authentication model for their users. Once they get authenticated, to actually create a volume, they go ahead and use a storage class, and then the Kubernetes can send a command to our storage system, and that gets authenticated. So we only trust Kubernetes in this model. Okay? What we do, too, is our secrets that we use to generate tokens are stored in Kubernetes itself. And the tokens that are generated are also stored in Kubernetes itself. Okay? And I'll show you what that means. So the very first thing I'll show you is the secrets. So KN is my alias for kube system, kubectl-n, the kube system. Because that's too much to type, I just type KN. So if you want to check, you say kpods, that's all the kube proxy and things like that. So if I type get secrets, and I just go for px, you see here that I have a section called px keys. Now, px keys is the shared key that are used for the token authority and a token verifier to determine if the token is okay. So what we do with that is I can go to refresh tokens. I can show you how that works. Let me actually show you the information that this is specific to my little tiny program that creates users. You can create your own way, your own token generator. But if I say here is a cat admin, here's the administrator YAML. It's the name, the subject, the email, the roles, and the group. Group star is specific to Portworx, meaning you can use any volume, any resource, doesn't matter. Okay, so this is the admin, the storage admin. If I do this for Kubernetes, then we look at the information that we have here for Kubernetes, and so on. So I have a little refresh keys. Okay, and we're going to just run this one line here for the authent just to show you. Actually, let me run this first. So we're going to get the secret that's on Kubernetes itself. I'm going to say echo secret. Shh, this is not recorded, right? That's good. So that's the secret that's being used to generate tokens. And we're going to generate a token just for fun. Going to give it a 7-day token. And that's the token right there. That's how it looks like. Okay? If you want to see what it's inside a token, we can go to here. Let me just get out of this and go to jwt.io and paste it here. And then you can verify that your token information is correct. See? Here's the admin, is on role system admin, and so on. This is a good way to verify what's inside your token. All right, let's go back here. All right, so the next thing that this little program does is that it inserted the tokens in different namespaces. Now, when I show you the CPXSC, I have a storage class, and this is how it works. The storage class refers, this storage class specifically, refers to a specific token, and the token is the Kubernetes user token, right? So that way, anyone that uses the storage class uses that token. So that's fine. Now, what if we wanted to have 2 tenants separately? Now, we're not going to discuss how you do that networking and things like that. We're just talking about the storage system and how you do different volumes for each. So what I did here is I have 2 namespaces, one called tenant 1 and one called tenant 2. And then I go ahead and create a secret in each. And each one of those has a token for each one of those tenants. Okay? So when I look now at the storage class for the tenants, you can see, and again, this is all based on CSI, you can see now that the namespace is the namespace of the PVC. That's very important. So what happens is that if I'm calling from tenant 1, then I request a PVC with this storage class. It's going to go to my namespace and look for the token that defines me as tenant 1. Okay? If I do the same thing for tenant 2, it's going to go to their namespace and find the secret for them and use that to make calls into the open storage SDK. So why is that important? That is very important because what happens is that if at any point in time any of the tenants becomes malicious and tries to get the access to the data of another tenant, it will not be possible because the API will protect them from that, right? So you have protection from Kubernetes at your level for using namespaces, and then you got protection now from the storage system itself. Okay. Let's go back to the slides. Here we go. So a couple of last things. Now we have just a few minutes left. On how is it that we generate documentation? There is some really cool programs out there, like there are generators, just like you have protocol buffer generators for different languages. They just output in that language. There's one for Markdown. So you can actually go through your entire protocol buffers file and generate all the documentation. And lastly is I highly recommend you guys do this if you have protocol buffers files, is that you version them. We have a link here, how is it that we go ahead and do that in our system, but that makes it that the file itself is versioned, and then you can use that information at any point in time, for example, for the client to request the version information from the server. That way you can check for any situations where they're not matching. All right, that's all I have. Again, the slides are right there on my GitHub, and I have just about 5 minutes for questions. If not, I'll be out in the back if you want to meet with me. And if you have any more questions, then I got some socks to give out. All right, everybody's ready for socks. Thank you. All right.